Heavy industry, such as steel manufacturing, oil and gas, and chemical production, is a critical component of the global economy, representing about 15% of global GDP. However, these hard-to-abate industries are a major contributor to climate change, with direct CO2 emissions around 9 gigatons annually.
Various industrial sectors, there are hard-to-avoid CO2 emissions, and for those emissions it's critical to develop a circular carbon economy. For example, in the steel industry, even after electrification and after hydrogen-based steel production routes, there will still be unavoidable CO2 emissions because carbon is inherently present in the steel. Therefore, CO2 emissions will be remaining, and to get to net zero, a circular carbon economy is important.
eChemicles has been working to solve this problem. We have been developing electrolyzer technology to convert waste CO2 into industrially useful chemicals such as carbon monoxide.
We have reached an important milestone in the development of our CO₂ electrolyzer system. After operating successfully our alpha prototype for about a year, we collected extensive operational experience that helped us refine and optimize our technology. Now we can say proudly that our beta prototype is up and running.
The container you see here is a major milestone in the history of our company because it's the first container that's being shipped to our customer.
It is an important step for the CO₂ electrolysis technology to move towards testing with real industrial flue gases. Therefore, I'm very proud that K1-MET together with eChemicles can for the first time test this technology with real flue gas from the steel industry, captured by amine scrubbing and then directly going into the CO₂ electrolysis unit.
We are very proud of achieving this step. Having our container tested externally at an external site means a significant milestone. So far, we have tested our containerized systems internally with different CO₂ gases, and we validated that it works. And now it comes to a stage when an external customer will validate that it works in their environment. This marks an important milestone when this beta prototype system will be transformed to a product available to customers already next year.
Now, they chose our container and technology in particular because it fits in with the technology that they have already, so they didn't have to make any changes to their infrastructure. It's also low energy, so it could actually be utilized with the sustainable energy systems that they have. So it's a great partnership, and we're delighted to actually send it to them.
So CO2 just needs electricity to convert CO2 to CO and other chemicals. Therefore, the electricity demand is an important parameter. And next to this, stability of the technology with real industrial flue gas is an important step to move towards an industrial use case. And then the overall carbon efficiency also matters. For the hard-to-avoid CO2 emissions, CO2 capture and utilization technologies will be vital to convert it into carbon products and create a circular carbon loop. So we hope that this is a first starting point for a long-term future collaboration where we will together look into the full potential of the technology and see where it can find its role in the steel industry, but also in other industrial sectors.